I'm going to explain refraction of light at a curved surface. Curved surface. Today I'm going to explain activity 2. Activity 2. Activity 2. Activity. Activity. Activity 2. It is so focal length of the lens. This is a convex lens. Convex lens. This is a convex. Convex lens. Convex lens. So we are going to find out the focal length of the convex lens. Focal length of convex lens. Convex lens. So focal length of the convex lens. Convex lens. So we are going to find out. So we have to find out focal length of convex lens. Convex lens. Convex lens. Focal length of the convex lens. Therefore, suppose for example, now I'm taking this is a glass tumbler. This is a transparent glass tumbler. This is a transparent glass tumbler. Transparent glass tumbler. Now this is a stone. The stone. This is a stone. I consider one stone. The stone keeps on bottom surface of the vessel. Bottom surface of the vessel. So this is a vessel is empty. This is a vessel is empty. The vessel does not have the water. So this is the vessel filled with the air. Air is present. Air is present. The vessel is filled with the air. So next this is what type of lens convex lens. So I'm taking the one stick. This is a stick. This is a stick. This is a stick. Convex lens. This is a convex lens. Keeps on this. Convex lens keeps on. Here. This is a convex lens. Keeps on this arrangement. Now, so this is you keep this one. This is a lens. Lens is front. Lens is front. Now, so this stick, this is a stick, this is stick. I'm sitting to be here. I'm sitting to be here. Why is front? I'm sitting here. Now, so what we have to do here is, what we have to do here. Now I'm going to find out the focal length here. So the medium is here. Medium is A. Medium is A. Medium is A. Medium is A. This is an A. So first we are going to find out focal length in A. Focal length of the lens. Focal length of convex lens. Convex lens in A. Is how can you find out the focal length of the convex lens? The air means, suppose for example, we know one thing. So this is suppose for example this is alternative. Alternative. So this is a lens is the place here. This is a convex lens. So we are standing here. We are standing here. This is a stone. This is a stone. We are standing in this place. So here, you know, this is to F1. This is to F2. This is F2. This is F1. This is to F1. This is a stop is placed here. Take this is a C1. Now this is a you take a C2. Now reading is from here is from here is 16 meters. 16 centimeters. From here is 18 centimeters. From here is 18 centimeters. Total 16 centimeters. How we are checking now? We don't know exactly. So we are checking like this. Now this is a person. Okay, but this is the elbow of stick. This is elbow of stick. This is a person. Elbow of stick. This is this is a stick. This is a stick. The stick holds the convex length. So this first of all, this stick keeps here very near. Ready? Sticks keep here. So we are seeing the stone to the X. This is a stick. Stick keeps. This is a stick. This is a convex lens. Convex lens keeps very near to the stone. Convex lens is. This is a convex lens. Convex lens keeps very near to the stone. I'm standing here. I'm seeing to the stone. I'm seeing to the stone to the convex lens. Okay, I'm finding the stone. The stone is someone's point of my point is K. I'm taking the K. I'm seeing, suppose for example, I'm seeing the K letter on the stone through the convex lens. I'm not seeing I'm seeing. Suppose this is shifting to backward. Convex lens shift to backward direction. Convex lens convex lens keeps away from the lens. Again, I'm seeing to the, I'm standing here, so I'm standing. Suppose for example, I'm standing here. I'm standing, C2. Now, this is a lens is keeping here. Lens is keeping here. The lens is keeping here. Now, this is object. Original object. So lens, this is a lens keeps very near to the stone. I'm seeing to the K letter on the stone. I'm seeing somewhat clear. Now this is a sitting backward. The sitting backward direction. Now I'm seeing to the letter K letter on the stone very clearly. Size of the object is I'm seeing as this stone, same size of the stone and K letter I'm seeing size of object is equal to size of it. Size of object is equal to size of I'm seeing to the K. Now this is shifting to somewhat it is now say suppose for example this is the stone having letter is K. I'm seeing here I'm seeing to the K letter. K letter. I am seeing to the K letter through the optic center. To the optic center. Now position of the stick is position of the convex lens is at this place. I'm seeing to the K letter. Suppose for example this is a position of the convex lens. I'm seeing to the K letter. This is the position of the convex lens. I'm seeing to the K letter. Now at this place. This is at this place. I'm finding the very clear. I'm not finding the K. This is a length of it. This is a length of it. So convex lens at this place. This is a position of part. This is a arrangement. This is a convex lens keeps very near to the stone and seen to the K letter through the apex center is flat. I'm seeing very clearly. Next, this is a convex lens shifted to here. I'm seeing to the K letter very clearly through the lens. This is the convex lens shifting to here. I'm seeing to the K letter very clearly through the convex. This convex lens is shifted to here. I'm not seeing to the clearly K letter at this place. I'm not seeing to this place. From here to here is the length we are taking. Suppose 10 centimeter. 10 centimeter. 10 centimeter. Then focal length of the area. Focal length. This is a focal. We are saying that this is a length, one length. We are taking this one. One length I am taking. That is a 10 centimeter. Suppose in second experiment, this is A. It is good. Suppose suppose so I'm taking to this is a focal length. Focal length. I'm taking the same breaker. This is a transparent beaker. Transparent beaker. This is a vessel. Transparent vessel. This is a stone. This is a stone. Keeps bottom surface of the vessel. The stone having the letter is K. K letter. This vessel filled with water. Filled with the water. This is a filled with the water. The vessel filled with the water. Up to the vessel filled with the water. The vessel filled with the water. Meaning is the vessel filled with the water. Water. The vessel filled with the water. Now, this is a stick and this is a lens. This is a lens. This is a lens. So I'm at this place. I'm at this place. I'm at this place. I'm seeing K letter through the lens, convex lens. I'm seeing very clearly K letter. K letter. This vessel, no, this vessel. This one is water. Vessel filled with water up to top. Top. At this place. This is a convex lens. This is a stone. Stone having letter is K. Okay. This is a convex lens placing here. Placing here. Suppose for example, placing here. Placing. I'm seeing K letter is very clear. I'm seeing letter K is very clear at this place. This convex lens is shifted from here to here. Again, I'm seeing to the K letter very clearly. Very clearly, I'm seeing. Now this convex lens is shifted to upward. Again, I'm seeing through K letter very clearly. Very clear. Again, this convex lens is shifting here. Again, I'm seeing to the K letter to the convex lens is very clear. Very clear. Again, this is a shifted to, this is convex shifted to here. Again, I'm seeing to the K letter very clear. Very clear. Okay. From here to here is a distance. What is the distance? Compared to this is a distance from here to this, I don't know exactly this distance. This is L1. This is the distance between convex lens and stone is L2. This is the distance between convex lens and stone is L. This is a L1 and A. This is a L2 is the distance in a water. Water. Now let's see. So yeah, what is the conclusion? L2 greater than L2. So what is the meaning of this one? Focal length of the convex lens in water. Focal length of the convex lens in water is greater than the focal length of the convex lens in water. Water. That is greater focal length of the convex lens in a water. Focal length of the convex lens in a water is greater than to the focal length of the convex lens in a. This is so convex lens depends upon surrounding medium. Concave lens depends upon surrounding medium. Lens depends upon surrounding medium. Surrounding medium. Lens focal length of the lens changes from medium to medium. Medium to medium. This is focal length of the convex lens. Convex lens. Now your chapter is complete. The chapter is over. So I completed refraction of light at curved surface. Today your chapter is completed. Now I am going to explain uh, conclusion of the chapter. I'm going to explain conclusion of the chapter. You will see what I mean. In the chapter, keywords. Keywords. So what is the keywords in the chapter? So first is lens, focal length, focal length. Next one, focus, optic center, principal axis, principal axis, radius of curvature, radius of curvature, radius of curvature, center of curvature, center of curvature, curvature, focal plane, focal plane. This is the keywords. This is a keywords in this chapter. This is a very important. This is very important. Now, see. So, what is a lens? So first of all, keywords lens, lens, focal length, focus, optic center, principal axis, radius of curvature, center of curvature, and focal. Chapter means refraction of light at the curved surface. Refraction of light at lens. Chapter means refraction of light. Refraction of light at curved surface. Curved surface. Refraction of light at curved surface. Curved surface. See here in the chapter, refraction. Do you know very well? Light which bends from light bends from its actual path or entering into the second medium. Second medium is called as refraction. What is the meaning of the curved surface? For example, this is a curved surface. So I'm thinking this is a denser medium. This is a radar medium. This is a curved surface. This curved surface separate the radar medium denser. This curved surface, this is a curved surface. Curved surface. Curved surface separate the refractive index of the air, refractive index of the air, refractive index of the glass. Curved surface separates refractive index of the air, refractive index of the glass. That is a curved surface. Curved surface. This is a center. This is a center of sphere of which curved surface a part is called as center. Center of curvature means center of curvature. Letter is C. Center of curvature. Center of sphere. Center of sphere. Sphere. Center of sphere of which curved surface is curved surface is a part is a part is a part is called as center of curvature. Center of sphere of which curved surface is a part is called as center of curvature. Center of curvature. This is a literary C. This is a center of curved surface. Center of curved surface is called as pole. Pole. It is denoted by the pinnacle. It is denoted by the pinnacle. Pole. Center of curved surface. Curved surface. Center of curved surface is called as pole. Is called as pole. This is center. Next, a straight line. This is a line. Line joins pole. Line joins pole and the center of curvature. It's called as principal axis. Principal axis. Letter is P. That is denoted by the pinnacle. Line joins a line joins P and C is called as principal axis. Principal axis is called as principal axis. Principal axis. So next, principal axis. Principal axis. Radius of curvature. Distance from, this is a P, this is a C. Distance from, and distance from P to C. This is the radius of curvature. Radius of curvature means radius of Laterals or distance between optic center to C is called as radius of curvature. Radius of curvature. So next principal axis. This is optic center. Sorry, this is optic center. Optic center. Optic center. Lateral something. Center of curvature is called as optic center. Optic center. Optic center. Lateral. B. Lateral. And focal length. So now this is a center of curvature is over, radius of curvature is over, principal axis over, optic center is over, focal plane, focus, focal length we have. Next to normal, normal. So normal means this is the one point, this is a curved surface, this is one point, this is a one point, center of curvature. Center of curvature takes as a one point. This is a one point on curved surface. Line joins here, we call this is a null. You take any another point on curved surface, center of curvature is a taken point. This is we call null. This is one point, joins two lines become. This is one point become. This is we call. You see, this is a normal, also normal line, normal line, normal line. This is the direction of the normal. You see the direction of normal is this is a direction of normal. 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 Direction of normal changes from point to point on the curved surface. On the curved surface. Normal means line joins C to any point on curved surface. Curved surface. Next, direction of normal. Direction of normal changes from point to point on curved surface. Point to point. So point to point. This is the point to point. This is the keywords. In this keywords, lens, focal length, focus, optic center, principal axis, radius of curvature, center of curvature, focal plane. And you see the CC, center of curvature. CC means center of curvature, center of curvature. Center of curvature. Center of curvature. CC means center of curvature. Center of sphere of which curved surface is a part is called as center of curvature. Center of optic center. Center of curved surface is called as optic center. Principal axis. Line joins center of optic center and center of curvature is called as principal axis. Radius of curvature. Distance from pole to center of curvature is called as radius of curvature. Next, normal. Line joins center of curvature to any point on the curved surface is called as normal. Direction of normal changes from one point to another point on the curved surface. This is a basic point. This is a basic point. Now next, see the focus. So next to focal length. So you will see this is the rules and thermodynamics. This is a curved surface. This is a pole, center of curvature. Center of curvature. This is a denser medium. This is a radar medium. Radar. Light strikes. This is a light travel. This is a light ray travels parallel to the principal axis. Strikes convex surface. This is a convex surface. Convex surface. So what will happen? So we draw the normal line. Draw the normal line. This is a normal line. Light travels from radar to denser means refractory moves towards the this is a refractory. This is a incident. That is one. So next, this is a denser medium, radar medium, 4, and this is a center of curvature. Center of curvature. So light travels from denser. This is a light ray travels parallel to the principal axis, takes a convex surface. Convex surface. This is a normal line. Normal. Light travels from denser medium to radar means it moves away from the. You can actually meet at this point. So next, this is a for this one, optic center. Light travels from denser medium to radar medium. Denser medium to radar medium. Denser medium to radar. Light travels from denser medium to radar medium means it's bending away from the next. This is optic center. This is center. This is a denser medium. This is a radar medium. Light travels parallel to the principal axis. Light travels parallel to the principal axis. This is a normal. Light travels from radar to denser means it bends. It is bending towards the. This is the curved surface. That is a curved surface. Curved surface. Curved surface. So next, speed of rules. What is a rule? So this is rule. Next, type of lens. Type of lens. So we have the type of lens. Type of lens. Types of lens. Type of lens. How many type of lens we have? Sometimes. Suppose, for example, this is a transparent metal. This is another transparent metal. This is a one transparent metal. This is another transparent metal. This is a piece of over the first transparent surface. Now this is the radius is from here series R1. From here series radius is R2. Now you cut it to this one. Now remove the circle. What will happen? It becomes a convex lens. Convex lens. This is optic center. This is this is R2. This is R1. This is R2. This is R1. Raise up. This is a C2. This is a C2. This is we call biconvex lens. Biconvex lens. Why we are calling biconvex lens? Lens means bi means radius are not equal. Equiconvex. Equiconvex lens. Lens means radius. Radius R1 is equal to R2. lens. This is a one curved surface. This is a one curved surface. This is another curved surface. Another curved surface. Lens is bounded by the two surfaces. Lens is bounded by the two surfaces. One is curved surface, another also curved surface. Another also curved surface. Lens is bounded with the two surfaces. One is curved surface, other is curved surface of what direction. Lens is what type of lens? So convex lens. Convex lens is formed when means two track convex lens formed. Lens is formed transparent material is bounded with the two surfaces. One is two surfaces are curved surfaces. Two surfaces are curved. This is a convex lens. Convex lens. Next is concave. This is the symbol we are using now. Suppose, for example, I'm drawing here. We can remove this part. We can use this. This symbol is it is represented by the convex lens. Convex lens. Convex lens. But here, this is having two central curvatures. The lens having two central curvatures. The lens having two central curvatures. Two central curvatures. Next, another lens is another lens is the concave lens. Concave lens. So one material. This is one material. This is another transparent material. So we attach to this point. We remove this one. This is a radius of one. This is a radius of one. We remove this one, and we have to remove this part. It become this. We call this is a concave lens. Concave lens is bounded by the two surfaces. One is the surface, another is the surface. Two are outwards, one inward curved surface. Concave lens is bounded by the two curved surfaces are inwards. Two surfaces are inwards. So this is a optic center. This is a radius of one. This is a radius of one. We call this is C1. This is a C2. This is a C2. So this lens having two central curvatures. Two central curvatures. You can press in middle part. It will become like this. You can become like this. This is a. This symbol is represented by concave lens. Concave lens. This is a concave lens. Concave lens. This is symbol. This is a C2 lens. Next rules. Next rules. What is the rules? Next points. This is a one type of. Next we have a types there. One surface is plane, other one is inwards curved surface. This is what we call plano-convex lens. This is a curved surface. Sorry, this is a plano-concave. This is one plane is this is one surface is plane. Other surface is upward curved surface. This is a plano-convex. Plano-convex. This is a concave convex. Concave convex. This is a type of lens. Next, we are seeing the rules. We are seeing the rules. What is the rules? Next rule. Now I'm checking this is a lens, convex lens. First one, optic center, C2, C1. Up2, this is a 2, F2, this is a F2. I'm going to explain why I'm taking next time. So first rule, Ray one ray is passes optic center. Optic center. This ray is passes optic center. This ray goes straight. It is does not deviate. Second ray passes along the principal axis. It goes straight. It does not deviate. It does not deviate. This is a remember. For same rules applies for the concave optic center. This is C1, F1, 2F1, this is F2, this is a 2F2, this is a C2. Light ray passes optic center, it does not deviate, it goes straight. This is one more ray, this ray goes along the principal axis, it goes straight, it goes straight, it does not bend, it does not bend. Next rule number 2. Rule number 2. This is convex lines optic center, and this is C2 F2. This is a 2 F2. This is a F1 2 F1. This is C. Next light ray travels parallel to the principal axis. It strikes. This is the light ray travels parallel to the principal axis. Strikes convex surface. It is convergent and it is reaching to the principal axis. Principal axis. It passes. It is a convergent. It is a that is rule number 1. Same rules applies for this. Same rule applies for other things. This is F1. This is a 2 F1. This is a C1. This is F2. This is a 2 F2. This is a C. Light ray travels parallel to the principal axis. It is a divergent. This is a refractor ray. This refractor ray extend backward direction. This refractor ray extend in dotted lines. The dotted lines passes through. This is all. So we have the basis of rules. This is of rules. Now I'm going to explain convex lens act as a convergent, concave lens act as a divergent. Now in this explanation, I'm going to explain focus problem. This is now this is a race a trap. This is a light ray that travels parallel to the principal axis and strikes the convex mirror. It is a convergent. It's a convergent. This is one more ray. This ray is travels parallel to the principal axis and strikes the convex mirror, and it is convergent distance. This is one more ray travels along the principal axis. It is undeviated. This is optic center. It goes straight and meet at this point. So this is one point. This is a convergent ray. This is a refractor ray. This is one more refractor. This is one point. This is one refractor ray. This is another refractor ray. This is another refractor. Three refractor rays. Three refractor rays are coming to the this point and meet at this point. Three refractor rays are coming to and meet at this point because this is a convergent rays. Because this is a convergent rays. Convergent rays. Convex as a convergent rays. This is a convergent. At this point, we call focus. This is we call this is a focus. We call this is a focus. This is a 1. This is a 2. This is a 3. The three refractor rays are coming to the meet at this point. Wait at this point. The point on the principal axis. The point is called as focus. The point is called as focus. Distance from optic center. This is optic center here to here. That is a distance from optic center to and focus because focal. Focal length. Focal. One focal frame. What is a focal frame? I'm going to explain it. This is a line optic center. This is a C1. This is a F1. This is a 2F1. This is F2. This is a 2F2. This is a C2. This is a light ray travel parallel of principal axis. This is a light ray travels parallel of principal axis. This one pyramid is a divergent. This divergent ray extend the backward axis the broadening process of force. This is transfocal first. This is a light ray process parallel and this also we can extrapolate this point because this is focus. We call focus. So this is one point. This is a divergence. This is a This is a this is a 1 second term. This is a three or refractor rays. Refractor. These three refractor rays are moving away from the point, away from the divergent. So concave rays act as divergent ray. Divergent ray. This is a convergent ray. Convergent. This is a so next. This is I'm taking the convex. I'm taking this is a two year part, year two, this is a year two, this is object center, this is year one, this is a two. Year one, this is a variable C1, this is a C2. This is a C1, this is year one, this is a two year one, this is object center, this is year two, this is a two year two, this is a C2. So like this is a line, this line is passes, this the line is passes here because this is a focal plane. This is called focal plane. Focal plane. This is a line. This is a line is passes through the one. It is perpendicular to the principal axis. We call focal plane. Focal. Now this is a beam of light. It is coming and meeting this. This beam of light is here. It is converging. This is a beam of light. It is converging. This is a beam of light and converging and meeting this one. This is all these are coming from all these are coming from. So this is a line. This is a line focal line. This is a line passes through your one. Passes through because this is a focal plane. Focal line. So this is a line ray. It is both sides. It goes start and mid. Next this is as lines strikes at this point. It is divergent distance. Divergent. What finds a mean? What finds a mean? What finds a mean? And what finds a mean? So where it is meet? Where it is meet? So now we see to take meet and strike at this point. Extend this domain or we at this point. This always are coming from infinity. Coming from infinity. Always are coming from. So this is a focal plane, and this is all points. That is a key. That is a key. In this lens having, this is a lens. This is a lens having. This lens having two center curvatures, two radius of curvatures, two focal points, two focus points, two center curvature, two center of curvature. Lens having two center curvatures, so two focal points. Lens having. This is a convex. Next, image formation. Derivation of functions. Derivation of curved surface. Curved surface. Derivation of curved surface means very simple. And this what they have to put in this equation. L2 by b minus L1 by 2 is equal to L2 minus L1 by this is the derivation of curved surface. Derivation of curved surface. This is a derivation of curved surface. Here, very simple. This is a curved surface. Principal axis, object center of curvature. Object is placed here and strikes at this point. Normal we drawn here. This is the curvature at this place, and we draw the perpendicular. This is at the end. This is one more goes straight at this point. Here, image form. Image form here. This is angle we are taking. This is theta 1. This is point. I'm taking a point. And this is we are taking angle theta 2. This is alpha angle. This is a beta angle. This is a gamma. Okay, this is a diagram from here to here. We are getting this. This is a refraction example. N1 is air. This is a N2 is this is a refraction example. Water or gas, whatever you take. But object is where is the object in air? Object is in air. This is air. So where is image form N2? This is the image form here. This is a radius of curvature. Radius of curvature. This is a derivation of curved surface. Derivation of curved surface. Derivation of curved surface. In this equation, this is this formula can use the plane surface. Plane surface. How can you use the plane surface? R is equal to infinity. N2 by V minus N1 by U is equal to N2 minus N1 by R means what is R? Infinity. So N2 by V minus N1 by U is equal to 1 by infinity means 0. N2 by V is equal to, we are going to write this is a plane surface. This one we will use a plane surface. Plane surface. This is a derivation of curved surface. Derivation of curved. Okay, next remaining part I will explain tomorrow. Ending of the chapter. Remaining part I will explain tomorrow. So this is your chapter. Your chapter. Thank you very much.